kind of the beginning of the special angle values that we need to know. We're going to add eventually like 3 more rows onto this table and get a few more angles that we're going to know the values of, but this is kind of our starting point. These are the quadrantal angles. If this is 0 degrees, 90 degrees, 180 degrees, 270, and if you're back around to 0, 0 would be the same thing as what? 360, and you could keep going around if you wanted. Yesterday, we did an example where I said, find the 6 trig function values of an angle in standard position that has the point 0, -5 on the terminal side. And so we did our x, y, and r and found all of those values. I could have asked that question the same way, or a different way, and gotten the same values if I said find the 6 trig function values for a 270-degree angle, because these are common angle values. So these are going to pop up a lot. What we're going to do is draw a picture to help us get these values. You can draw it in your notebook, or on, if you are taping it in there, just draw it in your notebook. If you just want the table, you can draw it on the back, margins, whatever. This picture is going to help us. We know that if I'm talking about 0 degrees, I could take any point on this terminal side, and it would give me the same trig function values, right? The easiest point would be the ordered pair. What would be the smallest or the nicest x value you think we could use here? What kind of number is x? Let me ask that. Positive. So do you want to do like 1/2, 3/4, 7/8? 1. How about 1?
3.14.
3.14. There you go. It'll work. If you're on this line, what is your y value? 0. So 1, 0 would be the simplest value I could use there. If I were talking about 90 degrees, what's your x value there? 0. And the nicest y I could pick would be 1. You could take any positive y value, but 1 would be the nicest. Okay, if I'm talking about 180, what kind of x would we use? -1, and y is 0. And at 270, x is 0, and y could be -1. Alright, does everybody understand how I got those points? So this gives me x and y. We also have to have r for everything. Now let me show you something. For the first one, x is 1, y is 0. So I get 1 plus 0 equals r squared. So what's your r? 1. If I did this one, 0 squared plus 1 squared equals r squared, what's your r? 1. -1 squared plus 0 squared equals r squared. You would get r to be 1. 0 squared and -1 squared, r is going to be 1. So the nice thing about it, if we pick these points, in every one of these scenarios, r is 1. Have I lost anybody yet? So now we can fill out this table. We have all of the information we need. Blaine, would you flip off one of the lights there? Okay. So here's our table. What is the definition of sine? Y over r. Okay, so in that picture we just drew, we had our points. So at 0 degrees, sine of 0, we said r is always 1. So our y value at 0 degrees is 0 divided by 1, 0. At 90, sine y over r, so that would be 1 over 1, which is 1. And if you need to write out what we're dividing, you're welcome to do so if that helps you. At 180, my y is 0, r is 1, so 0 over 1 is 0. 270, y is -1, r is 1, -1 over 1 is -1. 360 is the same as 0, so you could calculate it again, or you could just write down the number from 0. We have a 0 over 1, which is 0 again. So sine basically has 3 possible values for our quadrantals: 0, 1, or -1. Okay. If I gave you this blank table as a quiz, could you draw yourself that picture and come up with those values? Does everybody know how I got them? So we're going to do this for the whole table. How do you find cosine? What's the definition of cosine? X over r. Okay, so at 0 degrees, x is 1, r is 1, 1 over 1 is 1. At 90, x is 0, r is 1, 0 over 1 is 0. 180, x is -1 over 1, which is -1. 270, x is 0 over 1, 0 divided by 1 is 1. Oh, sorry, it's not 1, it's 0. 360, you're back to the beginning. 1 over 1 is 1. Got a little ahead of myself. How do you do tangent? Y over x. Why don't you guys fill that one out? So at 0, y over x would be 0 over 1, which is 0. At 90, you have 1 over 0, which is what? Undefined. At 180, 0 over -1 is 0. 270, -1 over 0, undefined. And 360 is the same as 0 degrees, so you're back to 0. Okay, once you have these three, the others, you could keep going the same way, or we could use the properties we know. Cotangent is just the reciprocal of tangent. So what's the reciprocal of 0? Undefined. Reciprocal of undefined would be 0. So at 180, tangent was 0, so cotangent would be undefined. 270, tangent was undefined, so cotangent is 0. At 360, you're back to undefined. You could have also just went through and did x over y for each of those, whatever you're most comfortable with. Secant. What's the definition of secant? R over x. Or that's the reciprocal of cosine. What's the reciprocal of 1? 1. Reciprocal of 0? Undefined. Reciprocal of -1 is -1. 270 would be undefined. And at 360, you're back to 1. Okay. Cosecant is r over y, or the reciprocal of sine. So at 0 degrees, sine was 0, so cosecant would be undefined. At 90, sine was 1, so cosecant is also 1. (180) would be undefined. 270 would be -1. And 360 is undefined. Are there any questions about how I feel about this too? So, what I am expecting from you, I am not expecting you to just be able to rattle off tangent of 0 is 0. You know, sine of 270 degrees is -1. I don't expect you to be able to get them that quick. What I expect is that you guys could draw this picture, know x, y, and r, and figure out your values from there. Okay, so at this point, we are just working on understanding where these things are coming from. Some of these are going to, well, these values are going to keep showing up, some more than others. So it's really important that we know how to get them now. It doesn't take very long to go out to the side and draw yourself an XY axis and write down a few ordered pairs. So as long as you know how we're getting them, then we're okay. Are there any questions? So, let's look at an example. If I asked you to find the sine of (1,260 degrees). Okay. Next thing I want to caution you against is the calculator. Don't just type in sine of 1,260. Okay. Here's why. First issue is there are two settings on the calculator. There's a degree mode and a radian mode. Depending on which one your calculator is in, we haven't really talked about going back and forth, it might give you the wrong answer. Second of all, for these values, I'm not going to lie to you. Yes, your calculator will evaluate them for you. But we are going to be building off this and including things that have radical answers. And these calculators will not give you the radicals. So I need you to get in the habit now of not relying on your calculator for everything, because it will be very misleading to you later on. Okay, so for now, let's just work on evaluating this based on what we know. If I give you a negative angle or something bigger than 360, what do we do? Right, subtract 360. So we can use our calculator for that. Let's subtract 360 until we get something between 0 and 360. So you get 180 degrees. Okay, here's the second thing I'm going to caution you. I am fully aware that I just gave you a table with all of these values on it. Okay. But if you just look at this table the whole time you're doing your homework and write down the numbers from the chart, is that actually going to help you later on? No. So I am going to be giving you class time to work on the homework today because I don't want you to be rushed and feel like you just have to copy down the numbers from the table. I want to make sure you know how to get them, and I want you to practice that. So if I'm thinking about 180 degrees, where's 180? 0, 90, 180. What would be the ordered pair there? And we know r is always 1. Sine is y over r. So that's 0 over 1, which is 0. Okay, so even though you could just quickly do that on a calculator, please work it out by hand because that will help us when we get to uglier things later on. Alright, I want you guys to do one. I want you to do secant of negative 450 degrees. So what'd you do? Add 360. How many times did you have to add it? Twice. And you got 270. So where's 270? 0, 90, 180. There's 270. What's my order pair there? 0, negative 1. R is 1. Definition of secant is r over x. So 1 over 0 would be undefined. Use your table to check. Is that what we wrote down for the secant of 270? Yeah, so use that to check your work along the way. Is that what I did? I want to evaluate this expression. When you see secant squared 180 like that, what it means is find the secant of 180 degrees and then square your answer. The notation is to always put the square on the trig function, not the angle itself, so you realize you're evaluating, then squaring your answer, not doing 180 squared. So if we think about 180, that's the point negative 1, 0. We know r is always 1. So secant is r over x, so secant of 180 would be, so that's negative 1 squared, minus 3 times the sine of 360 degrees squared. So 360 is at 0, so this is the point 1, 0. Sine is y over r, so sine of 360 is 0. Plus cosine of 180. So at 180, cosine x over r, so negative 1 over 1 is negative 1. You're going to have some problems like this on the homework. If you just write down your final answer, I'm not going to give you credit. I want you to actually show me what you're doing here. You know, if I put this on a test or quiz, this line right here is worth 3 points, because I'm going to give you a point for getting the secant of 180, and a point for the sine of 360, and a point for the cosecant of 180. I will give you points for every trig function, so make sure you're showing me how you're getting your answer. So now we can just evaluate. Negative 1 squared is 1, minus 0, minus 1, and we get 0. So can you handle those on your homework? I want to do one more example. We're doing the cotangent of 2n plus 1 times 90 degrees. I want to think about this one first. If n equals 0, then what would this simplify to inside? 90. If n equals 1, you get 2 plus 1, so 3 times 90 is 270. Okay, so right now I'm thinking it could be here, or it could be here. If n were 2, that's 4, so 5 times 90 is 450. 450 is the same as what? 90. If I did n equals 3, that's 7 times 90, so 630, which is the same as what? 2. So even though I gave you this expression, we're seeing that the only place it's actually hitting is at 90 or 270. Okay? At 90, we know our point is x would be 0, y would be 1. At 270, it's 0, negative 1. Cotangent is x over y. Cotangent of 90 is 0 over 1, which is 0. At 270, 0 over negative 1 is 0. So no matter what, this expression is actually going to equal 0. So there's going to be a few on the homework like that. You just have to plug in a few n's and evaluate them to see what kind of answer you're getting out. So that is the end of section 3. I would really like to do a little bit of the notes from section 4. Would you rather I do that at the end of class or the beginning? Do you have a preference? At the end?
Yeah.
Okay, so I'm going to stop here for now and give you guys time to work. It's a lot of just evaluating these things from the table, but I'm giving you class time. So actually figure them out and then check your answer on the table. Don't just copy them down. As far as the picture, you don't have to draw it on every single problem. If you want to draw it at the top of your page and use the same picture as you work through your problems, that is fine with me. I don't expect you to draw that 20 times. So, we are ready. You can add this to yesterday's. We will turn it all in tomorrow. So on page 26, we're going to pick up with 56 through 60. I think the first one is